This is the second example. We'll call this one example 2 of a type 3 rational function. Continuing just as we've done before. So let's go straight away with the y-intercept. Let's move this on fairly quickly. Y-intercept is when x equals 0. So y equals 12 over x squared. What's 0 squared is 0. Plus 2 lots of 0, take away 3, which is 12 over negative 3, which is negative 4. So when x is 0, y is negative 4. Next, x-intercept is when y equals 0. And in this case then, we have 0 equals 12 over x squared plus 2x plus 3. Again, the yellow is dividing. So if I want to get rid of that, I'd have to multiply everything by that, both sides by that, or take it to the other side and it multiplies. This will imply then that 0 equals 12, which is false. So there is no x-intercept, just as we did before. And this is not always the case, but this is a different type here. So let's go for the vertical asymptote. And again, this is when the denominator equals 0. I'll just realize that should be a minus in there. Okay. So what we're going to do now, we can see it's a quadratic equation and we need to solve that. Now in this case what I've done is I've used one that we can factorize. So what we've got is x and x, two numbers that multiply to negative 3 that add up to 2 will be 3 and negative 1. So this implies that either x is minus 3 or x is 2. So here we have two vertical asymptotes, which is going to make that rather interesting. So let's have a look at the horizontal asymptotes. Okay, and this time then what we're going to do is we're looking at the behavior of y as x gets really big. And in this case we're looking at the right hand side as a fraction. So I'm going to divide both sides, sorry, I beg your pardon, top and bottom, all terms by the highest degree. And the highest degree in this case is x squared. So I'm going to divide everything by x squared. And as long as I do this to all of the terms, there's no problem with that. So what we end up with, this implies that y is equal to 12 over x squared divided by 1 plus 2 over x minus 3 over x squared. Again, this looks really messy, but as x gets really big and is approaching infinity, what happens to y? Well, what we're going to end up with is that y is going to tend to, like, 12 over something really big squared is 0. 1's on the bottom. 2 over something really big is 0, and then 3 over really big is 0, and we end up with 0 divided by 1, which is 0. So again we have a horizontal asymptote at the x-axis. I'm going to draw what we've got and then fill in the pieces. So we've got an x, we have a y, we have a 0. Right, let's go. What do we know? We know 0, negative 4. So 0, negative 4, let's say that that's down there. And that's our intercept on the y-axis. X-intercept, there are none. Okay, we have a horizontal asymptote at 0 and two asymptotes at negative 3 and 1. So 1 There's x equals 1. X equals negative 3. And we have an asymptote at y equals 0. Now clearly, trying to work out where the graph's going to be is a little bit complicated here. We have 1, 2, 3, 4, 5, 6, 7, 8 sections. Let's have a look at what we did before. Let's have a look at the critical values. So, when x is minus 3, we have an infinity, y. We've got x is 0, and y is minus 4. We've got x is 1, and we have infinity. So now we're going to look at the 4 sections. So, let's have a look. Let me just write down our function again so that I've got it. I believe it was 12 over x squared plus 2x minus 3. X squared plus 2x minus 3. And off we go. So when x is bigger than 1, so x is bigger than 1, which is the section to the right, we're going to look to every number bigger than 1 going to the right. We have on the top, it's positive again because it's a number, 12. On the bottom we've got positive squared plus a positive minus 3. Okay, so it will actually happen here that when x is 1, we end up with an infinite answer. Okay, so when x is 1 here, we actually end up with 0 on the bottom. But when x is bigger than 1, so let's say 2, we have 2 2's are 4, plus another 4 is 8, minus 3, so we've got positive over positive, which is positive. So this section, the graph is going to be above the x-axis. The y values are all positive. I think we could probably just put that in anyway. Let's put that in like that. Sorry, change colour. They're all positive like that. And again, they've got this general shape that we've seen before. Let's go between 0 and 1. So 0, x, and 1. So y is going to be, okay, between 0 and 1, let's say, it's going to be a little bit tricky, but let's say a half. Definitely positive on the top. Let's have a look here now. Half squared is a quarter, plus 2 halves is 1, so that's a 1 1/4 minus 3, we're going to end up with a 2. So this section is negative, okay. Let's have a look at the next section. We've got the next section is between minus 3 and 0. Let's have a look there. Let's say, oh, I don't know, negative 1, just for the heck of it. So we've got negative 1 squared, which is 1. We've got 1 minus 2 minus 3. So we've got 1 minus 5, which is negative. So that section is going to be negative as well. So we've got 2 sections negative. And then when x is less than minus 3, let's say minus 4, negative 4. When x is negative 4, we've got the positive on the top. Negative times a negative is a positive. So negative 4 times negative 4 is 16. Minus 8 minus 3. So that's 16 minus 11, which is 5, which is positive. So what we're going to end up with is that's positive. Now, what I'm going to do is that, because we have those asymptotes there, we know that the graph must come through minus 4, and it's always negative in those 2 sections here and here. Now this is it that we haven't got the mathematics for. How far up does that go? Where is the sort of maximum point of that curve? Well, we haven't got the mathematics for that, but what we have said is the graph must go through minus 4 and it must stay negative at all times. and it cannot cross over these asymptotes. Okay, these rational functions, any graph in fact, cannot cross over a vertical asymptote ever. Okay, that's it, we're done.